Problem 1, inclined motion. This problem is basically to bring out certain misconceptions. We've been given a car moving up the incline. Let this be the origin of the coordinate system. And x car, which is the distance from the origin to where the car is given by tan phi of t. The angle theta which the incline makes with the horizontal direction is theta. Now Rahul got clearly confused. In the car, we studied that to compute the velocity or speed, we plot the distance or displacement. I'm using it interchangeably because the motion is happening in the straight line. Xt is plotted with t on the horizontal axis, x-axis, and xt on the y-axis. Suppose the curve is like this. So speed at a particular point A, which corresponds to say t equal to ta, is given by the slope of the tangent, at point A. If this angle is alpha, then the speed at point A is given by tan alpha. Now what happens in case of uniform motion? The curve xt versus t is just a straight line. So alpha remains constant throughout, and hence the speed is tan alpha. Note that in this uniform motion, xt versus t curve is like this, happens to be a straight line, incline. That does not mean that the object is traveling in this direction. Vice versa, here in this case, the car is moving in the direction up the incline, which makes an angle theta. That does not imply that xt versus t also will be a curve, straight line, where the line makes an angle theta, because this corresponds to the direction of motion, while this the curve corresponds to how xt is varying with time t. So to compute the speed here, we don't have to worry about the direction of motion of the car, because anyway the motion is happening in the straight line. We just have to plot the curve xt, x car t versus t. So what will be the curve? The curve will be a straight line, and the angle would be phi, because x car is tan phi of t. So the v of car will be tan phi. Hence, Nikita is right.